We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, ZoomLock Max Press to Connect, and ZoomLock Push to Connect refrigerant fittings. If the folks want to learn more, what do?
You can go to Sporlan.com.
I guess that's Jim and John for Sporlan signing off.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. Here with the host, Brett Wetzel and Kevin Compass. What's up this week, man?
Oh, trying not to die in tornadoes as we're trying to start a rack on a roof.
You're getting tornadoes out there too?
Oh, yeah. We got last week was then today was hailing on the roof as we were on there and blowing sideways and great idea putting racks in the roof.
So it's funny you say that. So I went out to this week, actually Friday, I left at around noontime to take my daughter out to her first prom out in Arkansas because she has a remote boyfriend, because that's fine because he's far away. And as we're going out there, my daughter's sleeping. And I hear my phone just keep going off as we're driving. And so finally she wakes up and it's starting to get kind of nasty outside. I was like, sweetheart, I was like, check my phone. I was like, I didn't know what the hell was going on. And I didn't want to check it while I was driving because it's raining a little bit. You know, I was joking with her. I was like, man, they must have a lot of abductions out in Arkansas. And she's like, no, Daddy, we've been driving through tornadoes for the past 3.5, 4 hours. So, yeah. So all that demolishment that happened down in Little Rock. Yep. Yeah, we were right there. It was awesome. I called one of the guys I work with and that lives out in that area. He's like, what are you doing on the road? I was like, I didn't know there was tornadoes today. So, what's that?
Idiots.
No, yeah, it happens. So, what are you actually working on this week? I mean, besides you're setting the racks, or you're doing a startup?
No, we're starting the rack up. So, trying to pull vacuums in sideways rain and trying
doing the Forrest Gump thing. We got sideways rain, big old fat rain, stingy
Yeah.
rain. Do you have stingy rain today?
Yeah, it was stingy rain. Then trying to land all the wires and everything else, and figure out what's not on the prints that needs to be pulled and landed, and figure out what the EMS company did or did not program. And yeah, then play. Then tomorrow is case Russian roulette. So,
Wait, what? Why Russian roulette?
because you never know what you're gonna get. What sensor's gonna be in there? How many transistors are gonna be wired wrong? If you're gonna start the pulse valves up and they're gonna short together because white to white and black to black, or black to white in some cases.
You realize you just pulled that full circle because I was talking about big old fat rain. Now you're gonna cases are like startups like a box of chocolates.
Because you never know what you're gonna get. Like it's like apparently like you just wire the pulse valves together and away she goes sometimes.
Yeah.
Or like we started them up and like it was like case 1 pop breaker, case 2 pop breaker, case 3 pop breaker. You know what? Fuck it. Okay, let's go for case 4.
Well, good news. I got a whole bunch of guests that we're gonna end up talking to for me being down here in Cali this week. So that's a good thing.
Must be nice.
Hey, I don't know why you're not here. Apparently a startup took precedence over you training. So I mean, I don't get it.
I'm not doing startup. I'm just here to help.
Well, speaking of which, I guess we're gonna start talking about prepping a CO2 rack for startup. So yeah, I guess let's get into it.
All right. So first things first, you want to just look and see what you got. It depends on the manufacturer about how bad of a time you're going to have.
Box of chocolates. Hey, we're leaving manufacturers out of this.
Some of them are better than others.
True. Box
Some
of
of them are
chocolates.
better than others. Some of them you get chocolate. Some of them you get But
Hates
no,
you. You're such a dick.
you get for being late. I mean, just look over the rack, see what you got, familiarize yourself with it, look at the piping schedule, make sure there's not something like retardedly jumping out to you like that looks like it's piped wrong. I mean, I spend like an hour doing that. Just following everything, just making sure that like the medium temp compressors are on the medium temp and the low temp are on the low temp. Because
Really?
oh yeah. Make sure the headers and the stickers are right. Don't ever trust the stickers.
Also check all your cases to make sure that the check valves are in the proper locale. How many have you found this week so far?
So like an idiot, like I was looking at these zero zone cases and I'm looking at this. I got my main guy Jake with me and we're both looking at it. I'm like, those fucking ball valves are in backwards. I'm looking at him like, son of a bitch. I'm like looking at it, he's like, I don't know. He's like looking at the Sporlan ball valves. They have a A and B on there. It's kind of confusing the way you look at it, but the A should always be on the evaporator side. Well, I forgot that Zero Zone's the only manufacturer out there that flips their fucking valves to the right hand side instead of the left hand side. So
Okay.
I'm looking at it and I'm looking at the case after the guy was having a panic attack. And I'm like looking at it, I'm like, yeah, fuck, that is backwards. I'm like, damn it. Like, because we had a bunch at the last store we started up. We had a bunch that were backwards. It was whatever. Shit happens.
So what? So they're not doing the ball valve with the check valve in parallel. They're basically just doing the internal check valve.
They're all the Sporlan valves with the internal checks.
Okay.
Except for Hussman, because they do what they want.
No, I've seen that. You're fucking killing me right now. You know that. Just letting you know that.
So we're looking at him, and you're like, and we're looking at him. We're like, oh, come on. And then I'm like, looking at it again. I'm like, oh, they come in the other side of the case. Like they're the only manufacturer that puts the valves on the right hand side of the case. So just checking that. I mean, that's a big thing. But like back to the rack. So you want to make sure on the rack, if you have any check valves or on ball valves, make sure they're pointing the right direction. I've been screwed so many times by that, especially liquid to suction, anything like that. Make sure they're pointing the right direction. Okay. Make sure that the stickers match the loops, meaning like make sure that is actually the medium temp suction and not the low temp. Because the last
Oh,
the guy putting the stickers on should be paid more than the guy doing other things, and they mix stickers up. And then, I mean, it's the guy, it's the fitter's job to check. But here's the thing, like, I mean, some of these racks are super tight together, and what they've been doing, a lot of them, they've been double stacking the headers, meaning the headers are one piece, and they just join them with a coupling in the middle. They're blanked off, but they're coupled in the middle. So unless you really, really trace out this piping, I mean, some of these racks, you lose it inside. You can't see where the piping goes. So, I mean, unless you really check it out. And unfortunately, the last couple of stores we did, all the suction stubs were the same size. They were all inch and like 3.
I was literally just about to ask that. I'm like, at least typically you'll have a little bit of difference
Yep.
in pipe size as far as the suction. So apparently not though.
They were all generic. So that's a big thing. Trace them out, make sure the labels are right. And then just double check the labels. And then I mark them with a check mark once I've double checked what label and the loop is right and the ball valves are right. Okay. Then after that, it's going through everything, making sure everything's tight, installing all the transducers. A lot of people argue against this. I install all the transducers, I pressurize them all, and I pull a vacuum on them. I want to make sure that they're all tight. I don't want to be messing around with leaky transducers later on, and it's just one more thing you got to do. So when I'm pressurizing this thing, I'm also using that pressure to set my high pressure controls on my low temp. And so I'm going through, I'm killing 2 birds with 1 stone. I'm getting the pressure up high enough. I'm checking my high pressure controls, set my low pressure controls, and then I'm going through the compressors, making sure there's no blank off plates. I've had a couple racks come in with high pressure blank off plates on the transcritical compressors. Carnot does this a lot.
Really?
They off the TC compressor discharge, because in Canada they have to blow the gas cooler up to like way over what the reliefs would be. So they have to blank off the compressors, or else the compressor reliefs will go off. So make sure we don't have those specs in the US, but make sure those blank off plates aren't in there, or else you're gonna have a real bad time when you go to start those compressors.
Yeah. Well, typically for most transcritical startups, from my understanding, usually they any store, whether it be Target, Walmart, whatever, it's usually pressurize that part of the system, usually about 100 pounds less than what the actual physical relief is set for. Is that
So
what you're seeing out there?
there is no spec for either one of those customers,
Oh,
including Aldi.
really?
They have they leave it up to the manufacturer, which most of the time they aren't pushing it. So I generally try to bring it up like 1,500-1,600 pounds on the high side. I mean, without the blank off plates, you're kind of screwed anyway, because it's going to bleed backwards to a compressor. You're going to get a little bit of bleed down. All I care about is if it explodes or not. So, I mean, well, to do the true test, you need the blank off plates on the compressors. I wouldn't trust the ball valve.
Really?
No,
So even the service valve. So I mean, like blanking off the discharge line,
they all leak.
you know. What? Really?
High pressure ball valves bleed through, every single one of them. I've never had one hold. They all bleed through. You got to sit there and work them, and none of them hold right. But
Even the service valves?
I don't. The service valves are touchy,
Okay.
but in order to do that to test that high pressure, you need to shut everything off and pressurize it up. I mean, 15 to 1,700 pounds, get it above the relief, but you're going to have to cap the reliefs to do it. So that's why having a transducer on there is important, because now you could use that for your leak down test. Make sure you don't have any leaks in the gas cooler, or you're not going to break a high pressure joint. And then pressurize the rack. Use the transducers in the cases, pick a couple, and then all the transducers on the rack, get the rack to even out in pressure. And then that way you could graph this thing. You could graph it, and if you're losing pressure right away, you have all those transducers on there to see. You could get a baseline. Now, if you do start losing pressure, this is where it gets kind of tricky. You got to start isolating stuff. This is where it sucks, actually, because all those check valves end up screwing you over. Because you have a leak on the rack, and you have all the cases isolated, or the loops isolated for the cases, it's going to bleed backwards from the cases into the rack.
Understood. And then that way you'll end up blowing off the reliefs that could be on the loops then.
Well, not blowing off the relief. So if you're say we're pressurizing a rack for a leak check, we're trying to do the whole to make sure we're bringing the whole rack up to like 550 pounds, and we're letting it sit for like 24 hours. If you have a leak in the rack, you are screwed, because, and if you have the cases, if you have the store valved off from the rack, just to make sure that nothing is going anywhere, it will bleed backwards into the rack because of the check valves. So if the cases are higher pressure than the rack, it's going to bleed backwards. So that's where this whole thing gets like super tricky. And I'm not a big fan of those ball valve check valves or the check valves there on the loops for that reason, just for the fact that it makes it almost impossible to isolate and like do a leak down check like this. So the last two stores that we had a leak in, we ended up having to dump some 448 in and then pressurize it and then use a leak detector to find it.
Couldn't just use regular vapor with the CO2?
It's so much easier to use like 448, like 48 pounds of 448 and some nitrogen. That straddles lead you right to. If you put CO2 in there, it would take you forever.
But once again, how are you writing that up in your paperwork? That's not really a thing that you're supposed to be doing, right?
Why? It's trace gas. 100% legal.
I guess.
Just like you would use R22 for a trace gas.
No one uses R22 as a trace gas. Whatever do you mean?
But I mean that's the only real easy non-time otherwise, I mean, if you put CO2 in there, it's going to take you forever to find that leak with a CO2 leak detector.
So let me just extremely, I just want to explain this. So this is upon not having any other thing in the rack besides that 448, trying to get that up there. So you're not going to do that on a system that's live.
Correct. I mean, this is pre-startup, before vacuums have been pulled.
I'm just making sure the statement is said, so no one's like, well, Kevin said you could put trace gas in. So now all of a sudden you have a CO2 mix with 448. But I guess it would be kind of like
It would never
impossible, but it would be hard to get in there if you had the two in there.
You'd have to really try to get that in there. I'd be impressed.
Yeah.
But I mean, so yeah, using a trace gas, I mean, it cuts down time on leak checking a lot, especially if you got rubber or you got Armo on all the lines. I mean, you're not cutting off Armo, and cutting off Armo is expensive. So, I mean, you don't want to be doing that, especially on something that's been mitered and all the joints are done. So you just want to make sure. I mean, every single rack that we've gotten in the last like 6 months has had leaks. I mean,
where are you seeing said leaks? I mean, you know, typically on the pressure transducers, but where else are you seeing it?
Pressure transducers, relief lines, relief fittings, you name it. Like joints on the rack.
Gotcha.
Cases, same thing. Cases have been like just brutal here lately. Like we spent 2 hours looking for a leak, and they missed like 3 joints in a case.
What?
Yeah.
It's horrible.
So, and unfortunately, like half these cases come in flat now. So
yeah,
I mean, it's been bad. So like I mean, it's getting better, but it's been bad. So checking through that stuff, making sure the fitters are diligent when they're checking cases to make sure they actually have pressure in them, and marking them when they're flat. So I mean that way, if they are flat, they could be pressurized and the leaks can be found. So you're not there on startup looking for leaks for forever.
Mhm.
Next thing is making sure all the EMS matches what's in the programming controller. So meaning
Okay.
temp sensors, transducers, types for the transducers are correct. The dip switches are in the right spot. All the relays are in the right spot. So going through the pop sheet and then testing every single sensor, making sure you're good.
I have a question for you. So when you're going through everything on the rack, because I mean, people will ask me when they hear you talk about stuff, and I'm curious, like, how long does that actually take you? So if you're going through line item by line item, make sure every device is hooked up properly in the EMS for just the rack, what is that typically taking you as far as time frame?
Probably about a day. I mean, so what I'll do is like when I first get on site, usually the first thing I do is start tightening electrical. So I'll go through all the connections with a torquing screwdriver. I'll torque every single electrical connection,
Okay.
go through all of them. And then I'll check all that. Usually takes me about an hour and a half, hour maybe. I'll go pretty quick through it. And then go ahead.
You doing high voltage too?
High
At the
voltage.
same time, you're doing this all the same shot. So you're doing the high voltage and what I'm referring to as the low voltage or control voltage all at the same time when you're doing this.
The way I do it, I work in lines. I go across everything. So I'll start from left to right, all the way across. Whether it's high voltage, low voltage, whatever's in that line of me doing it, it all gets tightened, and then I go down to the next row of terminals. And then
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
it's really loud. So I'll go through all that. And then next thing I'm going through is making sure all my ball valves are open. Make sure I go through the whole rack. Make sure every ball valve is open that's supposed to be open. And the ones that are supposed to be closed, I tag them with tape. I'll wrap them with blue or red tape. And I will go through all the ball valves. Okay. This thing is already pressurized when I got there, and they already said it was good, and it was under pressure. And then all I have to do is start doing vacuums. I am a huge proponent of getting the biggest hoses on there I can. If I can pipe it into the rack, it's nice, but it's kind of a pain in the ass. You can't, especially in these outside racks. I don't want to leave my $4,000 vacuum pump outside. So
Hooking up to the release, pull it from there.
I like to hook up to the release. So I use the blue vac hoses. I will take a half inch. Usually it's a half inch fitting relief on most of them on the flash tank. I will take a half inch hose and I will plumb that baby right into the relief tree and make sure it's open. And then I got a half inch hose pulling on there. Everything checks backwards to the flash tank. Now I will pull a suction relief on the medium temp and do the same thing. Low temp.
How about on the TC side? You hooking up straight up to the TC side, or are you just going to rely on pulling it through the flash?
usually on the drop leg, there's usually a quarter inch ball valve, like a stainless steel ball valve. I get, there's usually a transistor there. I take it out. I put a 1/4 inch by 3/8 flare adapter in, and then I pull off of that with 3/8, and then I put one on the low temp suction, whatever. If it's 1/4 inch, if it's 3/8, whatever, I don't care. The low temp suction is usually not as bad. If I got everything else, I mean, I'm pulling from enough that I'll be okay. So I'll start to pull down. Now I want to get all the case controllers on because I want the pulse valves on. Because I want to have as much equalized flow through this thing as possible. I want as much little resistance in the vacuum pump as possible. So I want to get all the case controllers on. I don't care if they're all set up or if they're all working properly. I just want to get them on and powered up and get them clicking because I want to get those pulse valves going. Now, while this thing is pulling a vacuum at this point, I go stop looking at it because it'll make you go crazy and it'll go slower if you look at it. No matter if it's tight or not, if you look at it, it goes slower.
I get it. I get it.
So then from there, I move on and I go inside and I start trying to get the case controllers taken care of. And going through each case controller, getting it addressed, which, God, it's just been like, it is the most boring thing ever.
Well, yeah, because most of these they don't come from the factory with the correct address. So you basically have to figure out basically how to get in each controller, change the address, change the baud rate, get it up online.
Why can't dip switches anymore? Dip switches were so easy. Like, it takes so much time to address all these. What I do is flipping dip switches.
Just do it like the Novar one where you have like all the way up to 128 addresses for the last jump, for the last dip switch. I get it. I get it.
Like super time consuming.
Well, yeah, because then once you get those all online, right, and then typically what if you're dealing with an E2, right, you have it set up as to pull the program back from the controller back to the E2.
No. The target's the opposite now.
Well, hold on. My question is, do the case controllers come programmed from the get? Okay, so that's what I'm saying. So wouldn't you first?
Some of them are, some of them aren't. This is where it gets tricky.
Shit.
So this is where it gets tricky. So the new directive is to push them all from the controller back down, because.
But don't you first initially have to pull it back to get the address back, right?
No. You are physically putting the address in. So like with the SC3 controllers. So Target is using BACnet. Great. They're using BACnet for everything. No Ethernet connectors.
Okay.
They're using BACnet for every single case. So in order to do this, you got to go through each Sporlan controller, and you got to program a BACnet address in there, and you have to enable the BMS. Which, thank God, you could do it on the latest app update without the password.
Mm-hmm.
So, but you have to log into every single controller. You have to go into parameters, and you have to program that. And then once you do that, you go to the E2, and you force a BACnet scan under the network, and it'll pick up that BACnet ID.
Okay.
That BACnet ID is specific to that case, the way the case is spelled out. So if it's A05C, that BACnet spells out A05C in numerics.
Yeah, I get it. That's when you go through if anyone out here there is taking the Sporlan S3C contractor training, there's a good explainer on actually what Kevin's talking about. There's numeric value that basically gives all the case information about it being A01, whatever.
I mean, yeah, it's not something you like extremely need to know. I mean, if you're curious about it, yeah, look at it, but it's not like that's not going to help you solve an issue with the case. So I mean, if you guys aren't really like wanting to know that, I mean, it took me a little while looking at it, but if you're doing like BACnet programming, yeah, it's important. But so that the core links or where you really got to watch this at, because this is where it gets extremely frustrating. So when you go to program the core links, when you go to program the Modbus address if you're doing core links and you assign it to Modbus and you put your address in there, it automatically populates the backnet address. If that is anything but 0, it will not come online right. It'll come online, but it won't read any values.
Say that one more time.
In the core links, when you go to the addresses, so you go into system and you go to set the address and say you set the bus address at like 50, it automatically assigns a backnet address to 1. There's a backnet tab in there because those are Modbus or backnet.
Mm-hmm.
It automatically assigns the Modbus address to, or the backnet address to 1. If you do not change it to 0, it won't read right.
Really?
All the values read all messed up in the E2.
So you're Modbusing it, but you have to get rid of the backnet address, is what you're telling me.
Yes.
Or they get that reversed.
I spent 4 hours trying to figure this out today. And it takes like 5 minutes to do each controller, if not what, because you got to get into it, you got to plug a box in, you got to log into it, you got to log into it like 7 times.
So you don't need the. So you're talking now about the core link, right? Okay, I'm just making sure because I was curious how that works with the S3C, because I mean, for most kinds of programming that you have to do with that, you need the date code for those, right?
No, well, you do and you don't.
All right, well, let's not get into that right now.
I mean, you can do all the the address changes off the app without the date code.
Gotcha.
So you can get that far. Now, once you start getting it online, and then you can start pushing the programs back down to the E2, whatever you do. I haven't done any CC200 yet, but I mean, I would imagine that's got to be a year.
Yeah.
I mean, the case controller part takes longer than anything. Okay, so once you get them all online, now this is where it gets kind of tricky. Okay, go around, make sure you don't see any fans out. You do that. You can't really start checking transducers and everything else until you get pressure in this thing. I make sure all the transducers are open in the cases. Make sure they're all mounted. Make sure they're all open and good to go. Now, once I get my vacuum to where it needs to be, then I'm going to break this thing with pressure. Okay. For some god awful reason, you can't get vapor tanks up here. So stop caring about that a while ago.
Turn them upside down.
So I don't care. As long as I get pressure in the rack and it breaks the vacuum, that's all we care about. Once you get pressure in there, however you get pressure in there, if you want to put it in its vapors, as long as there's pressure in there, and you get pressure all around the system, then you can start checking transducers, making sure they're all reading the same. So what I do is I'll just get on the E2 if I have that, and I'll hit control page down through every single case controller and look at the suction pressure, and they should all. I'll just do it real quick, all through all of them, and make sure they all read the same pressure. If you got one that's reading minus 60 or like something crazy like 380, you know you got a problem.
So what Kevin's saying is, so if you go in there and go menu 5, configured applications, go to whatever case controller you're talking about, whether it be the S3C, the Core Link, or the XM, or the CC200, and hold down the control button, hit the page down button, and if you do that while you're reading the transducers, it'll skip through every single case, so then you can see what each case is actually running, because theoretically, if you're pressurizing the system to the same pressure all the way around, theoretically every single pressure transducer should read the same pressure.
Yeah, I mean it's a baseline test. Like you're gonna know if you're like way off. You're gonna find all the open or short transducers, and that's generally what it's gonna be. It's gonna be either it's valved off, it's not reading, or you have crisscross wires. So you're gonna find that right away. Then you're gonna go through, and after that's done, you're gonna start checking temp sensors. Now, what I'll generally do is I'll have a guy downstairs, or I'll be downstairs with my laptop. I got like 10 cans of duster, and I'm gonna shoot the discharge air sensor to make sure that one's right, and I'm gonna shoot the suction line temp sensor to make sure that one's right. Make sure that it's on the right line. Nothing's crossed with any other sensors. Okay. After we do that, And then at the same time, I'm checking all the fans, making sure all the fans are on, making sure that there's not like some crazy something crisscrossed, making sure that's good, making sure all the values read. Then once we're good with that and everything's verified, then it's time to bump the compressors. So I will go through each one individually. I will override the low pressure switch manually if I have to. I'll drive it down, and I will force compressor 1 on, make sure it runs. Force compressor 2 on, make sure it runs. Then 3. Then I'll go to the low temp ones and I'll bump them. I'll go through it all real quick. Make sure the compressor runs. Make sure there's nothing holding it out. Make sure there's not some stupid flexible combiner that's missing logic inputs or some calculation block somewhere that's broken and they won't allow the compressors to run. You want to be able to make sure that when you put gas in this thing and you tell it to go, it's going to go. You don't want to be like missing something out of a program, or they took something out of another program and try to combine it and it's missing some input or output, and sure that when you dump gas in this thing, it's going to go. So that's why I force the compressors on. When I make a call for a compressor, it runs the compressor. So that's you want to make sure that all those are good. And then if you have a refrigerant level probe, which has been a zero zone thing, I haven't seen anybody else use it with zero zone. They've been using hand rods. Make sure you go through and take the time and zero it out. So
I've never seen them on a TC rack.
Zero zone's the only manufacturer I've seen use them. We haven't had any issues with them. I mean, they've been fine. You just gotta set them up and calibrate them. So make sure that's good. And then make sure if you have your oil system is ready to function. So if you're using an oil eye, it's kind of hard to trick that out. But if you're using, go through the flexible combiner, cycle the input on for the oil eye, and make sure it drives the solenoid on. Or then vice versa.
And then you had said at one point, one of the things that you do is basically using the CO2, basically you vapor pressurize the separator or vaporize pressure the oil res, so you can watch the physical operation of all the pulsing to make sure all those go through, right?
Yep. So what I've been doing here lately, because we haven't really had vapor pressure, it's been hard to get vapor tanks. So what I've been doing is using an oil pump, and I pump up the oil reservoir. I valve off everything but the outlet. I pump it up, and I'll just cycle the compressors on and off. I'll cycle the switches. I'll have the breakers off, and I'll cycle the switches on and off, because here lately everything's been OMBs and OMCs. So I will cycle the switches off, and I'll let them fill up on the switches.
And no flexible miners for those.
Yes. I like them a lot better because there's none of that. There's none of that logic for guys to trip up over. There's less to go wrong. It's a self-contained unit. So, but I'll pressurize that with the oil pump.
Mm-hmm.
I mean, it doesn't take much. Pressurize that with an oil pump, and then that'll allow me to force the oil into the compressors. It doesn't take much, but it's just enough. It's flowing through the OMBs. There's nothing blocking them. They're functioning. They're working. But before that, you can make sure they lock the compressors out. So once you get to that part and you got oil in the rack, now it's go time. So basically what I'll do is I'll start up medium temp first, start charging it up. You could either charge it to the flash tank, or what I've been doing here lately is charging it through the cases. Meaning I charge it through, make sure it goes through the liquid dryer. So like Zero Zone's real good about this. They put a ball valve, then they have a 3/8 tap, then they have it goes through the dryer shell, then it goes into the store. So you feed the CO2 through there, it goes through the dryer first, which is how it should. So we've been filtering it off like a 163 dryer, and then we run it through the dryer into the case. Now, the reason I feed it through the store is if you feed it in that flash tank, you're only getting like 70 to 80% of the CO2 out of those tanks.
Oh, because of the pressure.
Correct. If you feed it in the store, you get 95 and 98% of the gas out of those tanks.
Gotcha. Just highly recommended because, once again, no manufacturer really recommends this. So make sure that you have someone up top side watching your watching your actual pressure or your level of your vessel, because there's no manufacturer out there that wants greater than 80% upon initial charge.
Yeah. I mean, an initial charge, but I mean, every time we end up putting more CO2 in after that. So just get it up to like, I usually go 50%. I usually charge my rack. Once I get up to 50%, I start opening it up and I stop charging and I open it up and let it rip. And then I will charge back on top of that whatever I need.
So when do you check? Well, because I mean, you miss a step in there unless you do it later. When are you checking the HPV and the BGV?
So like this before startup, like this before I start charging in there. Like I will physically force them if I can, and I will check the transducers, make sure they're reading what they should, make sure they're wired right. I will pull them off and make sure that the right transducer goes over. If it's a 326, I'll make sure the correct transducer reads open. Because I had that startup where really screwed me. They flip flop the transducers.
Oh, so the flash tank was controlling the HPV.
Yes, they flip flop the watt. So the transducers are reading off. So that's one thing you want to take them off. If it's like the iPro stuff, it's super easy. Just unclip it, make sure that transducer goes open. You're good. Make sure it's the correct transducer on there. And then with 326, I cycle the power to it and make sure that it's I can grab it. If it's a Danfoss, make sure it's moving. If it's a magnetic valve, it's got a nice readout on there, so you can actually see if it's opening or closing. It's 0 to 10 volts. If you have just ICMT valves, it's kind of hard. But if you want to drive them closed with your SMA, black and white are switched. So if it's a Danfoss valve, it's red, green, and then black on the Danfoss valve goes to white on the driver, and white on the driver goes to black on the Danfoss valve. So white and black are flipped if you want to drive a Danfoss valve.
So many stupid controls.
It does. I write it on the back. I have a label on the back of my SMA where I wrote it down there. So, because I forget. But no, I'll drive those open and close. On the iPro, for some reason, it doesn't work. If you try to force it open and close in the iPro, it doesn't work. It doesn't do anything.
Really?
Nope. It won't do it on the Visiograph. So I don't know if that's like an integration thing, but I know I brought that up to them and they were supposed to fix it. But 326, you can't force anything. So
you're only by lying to the sensors, that would be the only thing. Or using
force whatever the hell you want. If I want to force BGV, that works perfect.
I get it, but so like with the BGV, at least you can still run that with the SMA 12. The only other thing you could probably potentially do with the HPV is use like a signal generator and give it your own 0 to 10 signal and get it to ramp.
I'm gonna be honest, like the last like 5 racks I've done is we're not using iCads anymore, because technically those are done.
Yeah, what are you using for the HPV?
They're just using Danfoss ICMT valves.
Big silver guys with the pressure transducer already on it?
Yeah, or a Sporlan. Like this rack I'm doing right now has a Sporlan valve on it. So
they're really getting out there.
They've been out there. Zero Zone's been using them. But so like once you get those double checked, verified, then you'll cycle the power to that controller a couple times, whatever it is, get it zeroed out. Now you're ready to roll. Start charging this thing and watching it. You're going to start charging it slow. I like to go through the store because you get more CO2 out. CO2 is not cheap, so the less CO2 we could have in here, the better off we have as an initial charge too. We know what the actual.
It's not cheap. It's like supposed to be $1 something a pound in Canadian.
It's expensive. So and it's hard to get. So I'd rather not use all of it. So I charge to the store. Once it gets to 50%, or once we start creeping up like 30%, 40%, I'll shut the tanks off. I usually have 6 tanks going at the same time. Guy downstairs, flipping tanks, usually an apprentice. So I have the ability to flip tanks individually that will shut anything off. So it goes pretty quick. We're watching it. We're charging it through the cases. I use it 2 ways because it's a little more controlled going through the store. Okay, because if I need to shut it down quickly, I could shut the case ball valves. I said the ball valves coming in from the loops, and I can let the rack kind of catch up. I have more control over it from myself doing it this way. Because if you're just charging in the vessel, that thing can creep up real quick on you and blow the reliefs. If you do it through the store, you have a little bit more leeway with this.
Yeah.
And it's also going through the cases. So if you have any liquid flood back, it's going through cases that are 80 degrees probably.
Mhm.
So flashing that stuff off right away. So get it all flashed off and then get it charged up and then starting up cases slowly. I usually will go a couple cases at a time. If it's loops, I'll usually like turn on the first loop and I'll go a couple cases at a time. Just kind of watching it, make sure we don't got any flood back, making sure all the systems look good, and then we'll fire up a couple more cases and a couple more cases. I really wish all these manufacturers would put in like circuit switches and just do like inputs to shut down each individual circuit, because it'd be nice. It'd make startup a lot easier, but they don't.
Yeah, it's usually so they usually do it one of two ways as far as like with the restart function. They either do it off of time delay, right? So first case is let off right after 10 seconds, and then 120 seconds after, and 120 seconds after, and usually that's how they cycle. And then there's some manufacturers, Corel's doing this, RDM is doing this, where they're not doing the time circuit, they're basically bringing it on MOP. So maximum operating pressure. So if the pressure were to creep up, on the suction because of some other issues, it might potentially shut down a couple of those cases until the pressure comes back down.
I think all the staging programs are way too long. Like half of them, like just like shoot the rack in the kneecap. It takes so long. And the other issue is like if that rack goes down, it's super cold out, and the staging program's on. Forget it. That thing ain't starting up.
You might stall. No, I get it. I mean, it's something that the startup technician has to fuck around with, and you get it crystal, right?
Yeah, I mean, if you're starting up and it's cold, like and you can't get those tanks inside warmed up, you're screwed.
Gotcha.
Like the best thing you could do is hotbox it with I'll take all the tanks and I'll hotbox it with a turbo heater and a tarp. Just throw it over all the tanks and just let her rip in there so she's nice and warm. I mean, that's all you could do. I mean, but it takes forever for those tanks to warm up. It may get like the 60 under the tarp, but those tanks are gonna hold that temp for a while.
Yeah,
So
it doesn't sound fun.
So yeah, getting that in there is kind of like a pain. But once you get it started, you start going, a couple, things at a time. You're gonna find the flood back eventually. It's gonna find you. It's gonna be a case where something's gonna be jacked up. A sensor's gonna be reading 320 degrees on the suction, but hopefully you found that first. Or like the electricians are gonna turn something off, or something's gonna short when it starts to work properly.
Fans are on something stupid, and it shuts down. But I guess I don't know. I guess with the implication of case controllers, I guess that wouldn't happen nearly as much now, because most of the case controllers are controlling the light schedules anyway.
Well, yeah, but then when the lights are tied to the fans, I mean, still the same shit.
Yeah, true. All right, now forget it. Never mind. I thought it was less likely to happen, but you're absolutely right.
Especially when the light relays are right next to the fan relay. So
who does that? Why would they do that?
I don't know, but yeah. I mean, just going through and checking all that stuff, and then just slowly starting this thing up and just watching it. Make sure your gas cooler. I forgot that part. Like, make sure the gas cooler's programmed. If it's a Goodner, call them and get them to send you the program. And if it's anybody else, I mean, they pretty much, the BACs are like super simple. You just tell it you're giving it a 0 to 10 inverted if it's got to be that way. Make sure the fans ramp up and down before you start it. Make sure you got complete control over the fans.
You do want to make sure the dump valve for the water is working properly. You want to make sure the pressure regulator for the flow is set properly. So there's some other things that you need to do that.
Water on startup?
What?
Serious? Oh God, no.
Did you say there's no water on startup ever?
Do you really think the plumber's going to be done? No. The last 4 of these we've done, they've had a garden hose hooked to them.
So part of the prep should be making sure you're planning the job properly with the plumber to make sure that he's gonna. Right.
They just like disappear on the job site. Like nobody just like You're lucky to have water. I don't think we've had water in any of these, but I like the one we have right now. They don't even have the water line even close to where it needs to be. But like we don't need it anyway.
I guess not yet, right?
No, and we're not gonna need it for another 2 months up here probably. So I mean, yeah, I have never had water, and if we do get water, we don't have to drain, so we can't run no water.
Oh, just drains up on the roof then, right?
Absolutely not.
What?
Oh yeah, I got in a lot of trouble for that. So
Damn, dude.
they were more upset about that than running the garden hose. So yeah, I mean, like making sure you got water, making sure that all works, making sure your gas cooler works, and then just start this thing up slow. Go slow, don't goose it. I mean, as you do more and more of these, you get a little more loose with it, and you could start them up a little bit faster.
I mean, you find shortcuts, right?
You find shortcuts, yeah. I mean, don't get me wrong. There's shorter ways to do everything, but like do it the right way. But like the right way to you may be different than the right way to somebody else. But at the end of the day, it still gets started up and it still works the same way. The more time you spend making sure all the case controllers are good, the less problem you're gonna have. Making sure sensors aren't flipped. That is the biggest thing I see is sensors that are bad, sensors that are flipped, and stuff that gets missed like that, like the pulse valves tied to the lights, the pulse valves tied to the fans. The fans are the pulse valve output.
Really?
Oh yeah, happens all the time. All the time. What?
Oh my god! No, it's just I don't know. Whenever you tell me about startups that you're doing currently, I just remember when doing startups, it wasn't nearly.
Oh yeah, like 5 years ago it was.
Yeah, it wasn't nearly as bad.
No, we spend more time fixing cases and so. All right, we'll do a second part of this, like the actual like tuning and cleanup and everything else. But all right, guys, have a nice night.
Later, guys.